I know I got cut off on the last video, but I'll pick up here. I cleaned it up a little bit. Everything's still the same. We're still dealing with our pi over 4 angle measure here in standard position. Our adjacent side is square roots of 2 over 2. Our opposite side is also square roots of 2 over 2 because we're still in that 45, 45, 90 triangle. So we were going to find the secant of theta. We know the secant is 1 over cosine. I'll also put here that our hypotenuse is 1. And so cosine is adjacent over hypotenuse, and therefore secant is 1 over that. So just like we did for cosecant, if you'll follow the work that we did for cosecant, the secant of theta is going to be the square roots of 2. It's 1 over the square roots of 2 over 2. We flip the bottom, multiply, rationalize, all that kind of stuff. And finally, we're going to see what the cotangent of theta is. Since the tangent is opposite over adjacent, we know cotangent is adjacent over opposite. And again, that's 1 because the square roots of 2 over 2 divided by the square roots of 2 over 2 is 1. So there are all 6 trig values, exact values, for our angle measure of pi over 4. And these exact values are going to have a lot of meaning for us in trigonometry. We're headed toward talking about the unit circle, and we fill out the unit circle with all of the exact values for these very interesting angle measures around the surface of the circle of radius 1 in the plane. So there are our exact values in quadrant 1. We've just paid attention to what's going on in quadrant 1 for our angle measure of pi over 4. Now I'm going to get rid of all of this that I have marked here because I want us to see something very important here. If we are in the plane and we have our right triangle in standard position, and we do have it in standard position, try to straighten that out, then the coordinates of this point in the plane right here, that is this distance horizontally, that's our x distance, and it's this distance vertically, that's our y distance, from the point of origin. Here's the point 0, 0 in the plane. Well, we know because the length of this leg is square roots of 2 over 2, we know the x coordinate to this point is root 2 over 2. We also know, because this length is square roots of 2 over 2, we know the y coordinate to that point is the square roots of 2 over 2. And what is so interesting about this, because our radius is 1, it turns out that the x coordinate of these exact values in the plane at our angle measures on the surface of this circle, the x coordinate will always be the cosine of theta, and the y coordinate will be the sine of theta. And that's true not just for this point, but when we see in our next lesson, that's going to be true for this point and for this point. And it turns out that it's true for even our quadrantal angles. It's true that the coordinates of this point right here in the plane are 1, 0. And it's true that the cosine of an angle measure of 0 is 1, while the sine of the angle measure of 0 is 0, because there's our cosine value and there's our sine value. We can think of cosine being equivalent to our x distance, horizontal, and sine being equivalent to our y distance, or our vertical distance. The coordinates to this point in the plane, x is 0 and y is 1. Remember, our radius is 1, so we know here that we have an x coordinate of 0 and a y coordinate of 1. That means that the cosine of pi over 2 has to be 0, while the sine of pi over 2 has to be 1. So we can even find the sine and cosine of our quadrantal angles based on being in this circle with radius 1. So that's pretty interesting. We'll look at that a little bit closer in the next lesson. I want to talk about how we continue to fill out sine, cosine, and therefore the other four trig values in the plane other than in quadrant 1. So here I'm going to drop my altitude again. I'm in that 45, 45, 90. We already said we know the coordinates of this point are root 2 over 2, that's the x coordinate, and root 2 over 2, that's the y coordinate. We know this is the cosine of pi over 4. We know this is the sine of pi over 4. But because I'm in the plane and I know how things behave, how points behave in the plane, if I wanted to find out what the sine and cosine were, let's say of 3 pi over 4, well, that's easy for me to do because I understand what the signs, SIGN signs, positive and negative, are. When I take a point and reflect it perpendicularly over that y-axis, then just going back to coordinate geometry, I know that I am on the negative end of the x-axis. So the distance here is the same as the distance here, but now I'm on the negative end of the x-axis, so this x coordinate has to be negative root 2 over 2. But I'm still on the positive end of the y-axis, and this distance is equivalent to that distance. So I know the coordinate to that point is positive square roots of 2 over 2. And because I know that, because we already talked about this is the cosine and this is the sine of that angle measure, then I can easily say I know what the cosine of 3 pi over 4 is. The cosine of 3 pi over 4 has to be negative root 2 over 2. And the sine of 3 pi over 4 has to be right here, this y coordinate, root 2 over 2. And I can continue to do that. I could now reflect this perpendicularly down here over the x-axis, the same y distance, and it's going to be the same x distance, and I can go all the way around that circle and fill out every single one of those exact values for every reference angle for pi over 4. Here's root 2 over 2. So I know that the cosine of pi over 4 is root 2 over 2. The sine of pi over 4, positive root 2 over 2. I reflect this point perpendicularly, just like we did, and that leads me to this point in the plane. So I know the cosine of 3 pi over 4, negative root 2 over 2. The sine of 3 pi over 4, positive root 2 over 2. I'm going to now reflect this perpendicularly over the x-axis, and that's going to give me this point, which corresponds to an angle measure right here of 5 pi over 4. So again, I know the coordinates. I'm in quadrant 3. I'm on the negative end of the x-axis. I'm on the negative end of the y-axis. Here's positive x, here's positive y. So I know that the cosine of 5 pi over 4 has to be negative root 2 over 2, and the sine of 5 pi over 4 also negative root 2 over 2. Now I pick this point up and reflect it perpendicularly over the y-axis, and that gets me to an angle measure of 7 pi over 4. And here are the coordinates. I'm now on the positive end of the x-axis, but the negative end of the y-axis. So the cosine of 7 pi over 4 has to be root 2 over 2, and the sine of 7 pi over 2 is negative, 7 pi over 4 is negative root 2 over 2. So I take what I know about what's going on in the plane from coordinate geometry, and I don't have to wonder what my sine and cosine is if I'm in the unit circle, if my radius is 1. This is only true in the unit circle where my radius is 1. And we'll talk more about the unit circle after we go through our 30, 60, 90 special right triangles. And I could even go further than one full rotation and still find an angle measure larger than 2 pi. Remember, there's 2 pi is one full rotation. But if I continue and go one full rotation and continue another pi over 4, that's an angle measure of 9 pi over 4, but I'm right back here at this same point in the plane where I had sine and cosine values for pi over 4. So the reference angle for 9 pi over 4 would be positive pi over 4. So I could say that the cosine, if I can get this to right, the cosine of 9 pi over 4 has got to be the same as it is for pi over 4. It's square roots of 2 over 2. And the sine of 9 pi over 4 has to be equivalent to the sine of pi over 4 because I'm at the same point in the plane, this point right here. So we can just continue to go around that circle and we can find these exact values for sine and cosine everywhere. Everywhere that we want to look, we can just continue. We could even go in the negative direction and talk about negative angle measures and find the sine and cosine of those values. So putting the sine and cosine, putting these special right triangles in the plane helps us figure out what our sine and cosine values are at these very interesting angle measures of 30, 45, and 60 degrees, or for us in radians, pi over 6, pi over 4, and pi over 3. So that's all we're going to do on this lesson. The next lesson we will definitely look at our 30, 60, 90 right triangles. We'll find our sine and cosine, and we'll build a little bit more on these ideas. So come to class next time and we'll work some homework over this.